record. This is a fresh lesson for you all, so I am going to use this time to record. It seems that one person is missing, so I hope that they'll be able to, oh, there he is. All right, there he is. Yeah, it's going to be a fresh lesson, so I am recording. Yusuf, just letting you know, I am recording. And I'll say it one more time. 7.4 is the exact same principle and idea as 7.2 in that you have to use your law, not of exponents, but law of logs this time to solve for the x. So here we go. Example 1, again, notice how there's not much of an explanation. We're going straight to the questions. Example 1, going back to physical physics, science, the Richter scale, instead of giving you the Richter scale in terms of an exponential, and base 10, we are giving you a logarithm based on an amplitude, alpha for amplitude. I'm just going to call that T is the period of the seismic wave, and beta, B, is a factor that accounts for the weakening of the seismic waves. So they give you it. If the magnitude is 5.5, if the period is 1.8 seconds, if the factor that accounts for the weakening of seismic waves is 3.2, what is the amplitude of the vertical ground motion? Okay, that's it. You might want to take out a calculator. I'm going to quickly do some mental math. Subtract 3.2 on both sides. This becomes 2.3 equals log of alpha over 1.8. And then what? At 7.4, you are going to be utilizing everything we have learned so far. I am not going to give you specific guidelines on what you should use because there are many things you could use, but choose one and go for it. Love you. My wife came down and got me fresh coffee. That's love, everyone. Find someone that will get you fresh coffee. Terrible plug and praise for my wife, who I fought with yesterday, by the way. You know, our first dating, our first relationship started with her bringing me coffee. So this is particularly special for me. All right, here we go. Now that I've made half of you throw up in your mouth, having a log of base 10, we can actually convert this to have a 10 to the power of 2.3 is equal to alpha over 1.8, right? Again, using your inverse knowledge, I didn't do anything special. I just did the inverse. I turned it into an exponent. And if you do that with a calculator, I'm pretty sure you can figure this out. Throw 10 to the power of 2.3 and then multiply the answer by 1.8. If I can figure out my calculator, 10 to the power of 2.3 times 1.8. The amplitude should be, stupid ad, 359.1, approximately 359.15 microns. Microns is basically micrometers, which is by units, micrometers. It's got like a reverse U. If you do physics, then you will know that that symbol is called a mu, M-E something, okay, a mu. Okay, Let's move on. That same idea is essentially going to be used for example 2. There's nothing complex about it. You just have to use your inverse knowledge or past knowledge of logs. So let's do it. Let's see. I'm going to clear this. I'm going to move this down rather. Take a look. Again, log to the power of x, log of base x, sorry, for the number 0.04 is equal to -2. What is the base? Well, you would imagine it's very difficult to plug in any numbers and actually solve it if you don't know what the base is. But knowing your knowledge of exponents, you know that this can be reverted or converted into x to the power of -2, giving me 0.04. You can do that. Right? From here, though, it's a matter of how you want to work through it. Some of you might just use your mental math and be like, okay, well, isn't this the same as 4/100? And so isn't this the same as 1/25? Right? So x to the power of -2 is equal to 1/25. Doesn't that mean x to the power of 2 is the reciprocal 25/1? Yeah. And so x could be a 5. Other people might do it in a different way, and you would be just as correct. Why? Well, how about I do it this way? I don't like the fact that I have a -2. So how about I do separate it like this? A -1 is equal to, -2 is equal to -1 times 2. So if I square root both sides, this should become 0. I don't know. Does this become something? I'm just playing around with it. Yeah, this would become 0.2. Okay, well, that is the same. If I do that, well, what would be, how do I get rid of this? A -1. I could put all of this to the power of, oh, sorry. How would I show you mathematically? Well, how do we do this? If that's the case, if I do the reciprocal of here, right? And then I multiply both sides by x, I divide both sides by 0.2, and essentially I'm cross multiplying. What I get is x is equal to 1/0.2, which should give me a value of 5. There's so many different ways you can do it. And this is what I mean. You can't, at this point in time, unfortunately, you can't just copy what I do. It doesn't make any sense just to do it and think that my way is the only way. It's not true. Questions for that one?
I got a question about the lesson. This is all already on Brightspace, right?
7.4, you mean? Or
Yeah.
this handout?
Well, both. Like the handout, and you said that the examples are filled out. I thought you said that at the beginning.
Correct. The answers are filled out. Everything is there. The video will be up as soon as we finish today's lesson.
Okay. All right. Thanks.
Okay. Let's move on to the next one. Same thing here. Again, there's nothing special about it. You can do whatever you wish. We have log of base 7, log of base 7. They are going to be equal to each other. So you can argue, therefore, that 3x minus 5 is, in fact, 16. You can just say that right away. So there's nothing special. You just 3x, add 5 to both sides. That's a 21, and x becomes a 7. You'll see more and more that the strategies that you can use to solve these questions are going to be very, very similar, identical to a lot of different things. You will see factoring, you will see trinomials, you will see inverses and power rule laws and polynomial functions and whatnot coming into play here. Okay. Just moving on. Any last questions? I'll give you a minute to ask away. Otherwise, I'm moving on to the last page. Okay, who just heard? Yes, go ahead.
Oh yeah, for example A, so the only reason we didn't do x is equal to positive and -5 is because x is the base of the logarithmic.
Ah, you mean for this? Yes, absolutely. Oh,
Yeah.
I'm sorry about that. You're right. Yeah, so this square root 25, it could definitely be plus or minus, but you know that a negative base would not make sense.
Yeah.
Sorry, I'm half not awake. I should have mentioned that. You're correct. You're absolutely correct. Right? It's just by convention or by law or by definition, a law cannot have a negative base. Good catch. Okay. Now, how about I zoom in a little bit so that we have more space for this one. All right. Oof, here we go. At this point in time, again, we're going to start using this. I'm going to consider this a pretty entry level question. In times like this, what do you do? How could you use the knowledge you already have to make your life simple? Well, first things first, let's observe. Do you notice that all the logs have the same base? That makes our life a lot easier because all the logarithm laws you can use now. Seeing as how that they're added together, you can actually rewrite this as log of base 2 is of that. Right? Because I saw that they have the same base, I figured, hey, if I make the left side equal to a single logarithm, then I can argue that the answer inside the logarithm, or rather the input inside the logarithm, 150x, is going to be equal 12. And that's the end of the question. That becomes 4 over 50. No, divide that by 3. Yeah, 4 over 50, which is 2 over 25. There it is. So that was an easy one. I know I'm not trying to like insult your intelligence or anything, but that same idea can be applied to B. I'm going to give you exactly 3 minutes after you copy this. I'm going to give you 3 minutes to solve part B.
Mr. Kim,
Yes.
how come when you put the two logs together on the left side, it became a multiplication? Or is that just the way that it is? Like when you put them together in an addition?
It's a law. It's a
It's a
law.
law? Okay.
So for example, log of A added by the same log base with a B, you can rewrite this as an identity as A times B.
Oh, so this is just a law that we have on the log sheet or on the law
Yes,
sheet. Okay.
correct. This is one of the main 4 that we learned. And again, I would say just focus on those 4. It will help you a lot. So you don't have to you look at it as a reference sheet. Anyways, yeah.
All right, that's good. All right. You can tell that I've sort of forgotten it, haven't you?
No, not at all. You know what? You're not alone. You're not alone. Just keep at it.
It's been a weird 2 weeks. We'll get back there though.
Right. One more minute. All right, let's get to it. I am going to go straight into our Word document, answer part B. We should be able to do these last few questions very quickly. All right. Same here. I'm going to get through to it. Log x plus log x to the power of 2. I can actually rewrite this as, oops, not equals. Therefore, I can say log of x times x cubed is equal to 12, which means that is log 10, of course, of x to the power of 3 is equal to 12. And guess what? That means 10 to the power of 12 is actually equal to x to the power of 3. You could, some of you are like, okay, I have to use a calculator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros is equal to x to the power of 3. So what times what gives me 12 zeros? Oh, 10 to the power of 4 multiplied by 3 times. Another way you can do it after you get that answer, you can also rewrite this as 10 to the power of 4 to the power of 3. 4 times 3 equals 12. So I know that these two equal each other. That is equal to x to the power of 3. And if you have to the power of 3 and to the power of 3, that means the base has to be identical to each other. Again, there are so many different ways you can get to it. The world is your oyster. You figure it out. Okay? I'm just giving you all these different options so that you can think in more ways than one. Let's complete example 4. I think as we move through these questions, you will see that I don't need to do too much. In fact, you should be able to complete most of them already. What would you do? Log to the power of log base 2 of this plus log base 2 of that. Anyone have a thought? Going once, going twice.
This is unrelated to example 4, but I think you put a cube in the first line when you meant to put a square.
Ah, correct. That is a square. Thank you. But you know, it's for example 4, it's exactly the same thing. Because they have the same log, I am going to do log 2 of this multiplied by that. And all of a sudden, yes, it looks like a polynomial or a trinomial, or rather a quadratic. Let's do it. If I multiply these, this is a difference of squares. Oh, so this is a, these are conjugates, so it will turn into x squared minus 9 is a difference of squares. This power of 2. And so I can continue this. I can turn this into an exponent. It's true. I also know that the answer to this must be a 2 because 2, it must be 16 because 2 to the power of 16 is equal to that. So I don't know how you want to do it. Let's say example 1. I can say 2 to the power of 4 is equal to x squared minus 9. So it's 2, 4, 8, 16. So 16 plus a 9 is equal to x to the power of 2. So 25 is equal to x to the power of 2, which means x could be plus or minus 5. And does plus or minus 5 work for both? Not necessarily. So let's leave that. Okay, let's leave that. X to the power, let's see. Another way you can do it is know that this has to be 660. Oh no, I guess it's the same thing. I was thinking crazy. All right, let's work on that. Correct, Jesse. Put them together in one log. Absolutely. Sorry, I read all these afterwards, right? So it's not even example 1. I guess I was wrong. From here, the reason why both, so we have x could be 5 and x could be a negative 5. The reason why both don't work, however, it all goes back to looking at the original question. Notice that log of base 2 has x plus 3 as well as x minus 3 inside. If x was a 5, well, this would be log of 2, base 2 of 8, and this would be log 2 of 2. It works. However, if I have a negative 5 in there, and if I have a negative 5 here, what happens to the number inside the logarithm? They become negative. And whether you want to believe it or not, if you have a base of 2, no exponent will give you a negative 2, and no exponent will give you a negative 8. Therefore, this is rejected. It is what we call an extraneous answer or an extraneous root. Mathematically, it is correct, but given the condition we have, it is unacceptable. Okay. The next example I'm going to show you does involve another thing with polynomials, or rather quadratics, but it's not so simple as just solving algebraically. Take a look. For part B, I'm going to need all the space I can get. So I'm going to clear this. Who would like some more time? Okay, please feel free to just raise your hands. I don't really mind. Otherwise, you can always look at the video if you are feeling shy about that. Part B, in this particular case, it gets pretty interesting. The question says to state the domain. You don't need to find an exact value for x because there is nothing on the other side of the equal sign, right? Instead, I want to know what values of x allow this to even be solved. So let's take a look. So what values of x will allow a logarithm to be solved? Let me rephrase that. What must be inside this bracket for the question to have an answer? Going once. Oh, I see a chat. A positive. Absolutely. So what does that mean? What is the domain? Well, we don't know what the domain is yet, but I do know, just from your knowledge of logarithms, this has to be bigger than 0. It has to be a positive. Does this look familiar to you? Going back to chapter 1, do you remember how to do these? Maybe not. So it would be easier, wouldn't it, if we had just this, right? Well, you know what? If this is all you know, let's start with that. Let's factor, giving ourselves x, a positive 3 and a negative 1 will give you a multiplication of negative 3 and an addition of 2. What does that mean? It means my x-intercepts are going to be negative 3 and positive 1. So this is grade 10, where you are able to identify x-intercepts, right? And using the x-intercepts, you can make a quick sketch of your parabola. This parabola is x squared plus 2x minus 3. I hope you agree. And this right here is when x squared plus 2 minus 3 equals 0. And this is where x squared plus 2x minus 3 equals a 0. At this point, some of you, it clicked. You know exactly what to do now. Others, you're frantically copying, so you still have no idea. How? So we were able to solve this. How would you solve this? Right? We were able to solve that x squared plus 2x minus 3 equals a 0 when x equals negative 3 and when x equals positive 1. When is it greater than 0?
It's greater than 0 when x is less than negative 3 and greater than positive 1.
Correct. All of this and all of that is when it is greater than 0. In other words, what is the domain? Well, if this logarithm is to work, x must be greater than 1 or x must be smaller than negative 3. Another way you can write that is interval of x belongs to an interval of negative infinity to negative 3 union 1 to positive infinity. Or another way you can write it is x belongs to all real numbers such that, x, so negative 3 is small, sorry. X is going to be smaller than negative 3 or comma, x is going to be bigger than 1. Right? So many different ways, but either way, you're stating the domain. All right. Last question. Hang in there. Example 5, I'll raise this page up very soon. It says, solve the following system of equations. This will go back to your knowledge back in grade 10. The very first thing you learned in grade 10 is, what does it mean to solve a system of equations? Another way you can say that is,
find where they intercept.
correct. Find the point of intersection. So And clearly, you see why you learned how to graph it, you solve it algebraically instead of graphing it back in grade 10, is because you can't graph logarithms very accurately, right? A log of base 2, 2x is going to be very high. And log of 4 is going to be something like that, okay? So it's going to be somewhere here where they intersect. I don't know where that is, but we're going to use our skills and techniques and tools that we've learned today. Take a look. I'm going to clear this. If they are intersecting mathematically, it simply means that this y value and this y value are going to be equal to each other, right? Because they're intersecting. And if they're intersecting, it also means that the log of base 2, 2x, is the same as log of base 4, x. So this is a fancy way of saying, solve this equation, please. And how would you do it? How do you solve a logarithmic equation where you have two different bases? By now, you're upset and frustrated with a panda constantly asking you to solve math questions. But what do you think? And you remember how to resolve logarithms of different bases. No? It's okay if you don't want to. There's a lot of ways to do it, as always. So here's one way you can do it.
So, Mr. Kim.
Yes.
Oh, hold on. Never mind. That doesn't work. I saw one law and it looked promising, but looking back, it's not.
Again, you know me. I told you before. I don't try to use that reference sheet of logs. As a student, I don't think I would have ever used it because I don't have the time and the brain capacity to memorize all 12 or 13 that we've done. Instead, I'm going to use whatever the main 4 that I've given you because that essentially solves a lot of my problems. Here, I have a situation where the logs are different. The bases are different. So I'm going to do something to make them the same. I think it'll help me. Take a look. I'm going to change the left side to be log base 10 over log base 10 of the base. Log base 10 of the input with a log base 10 of the base. I'm using the change of base formula. Right? And if I do that, remember log 10 of base 2, it's a number. That's actually a number. And so is this. So what I get in this case is, how about we cross multiply and let's figure out what log of base 4 is. Log of actually, I don't even need to do You know what? I'm going to go one step further. Yeah, you know what? Should I go one step further and use a law of log? Yeah, how about we do that? Log 2 of x right. Stopping right there. Would you agree that log of 4 is the same as log of 2 to the power of 2? You know? Let's assume you do. And knowing that if you have an exponent inside a log, I could drop it right down. This is log of 2x over log of 2 equals log of x over 2 log of 2. And then notice that log of 2 is a number. It's what is it? 10 to the power of something gives you a 2. It's going to be a 0 point something. But whatever that number is, I can divide both sides out of it. This becomes, I guess, divided out or multiplied out, leaving me a simplified log of 2x equals a log of x over 2, which I'm going to simplify as 2. So get rid of the fraction. I'm going to multiply both sides by a 2. And I'm going to force myself not to use a calculator. In fact, that's probably the only way to do this. Because I have a 2 there, I'm so close, in fact. Notice how there's a log here and there's a log here and they're both the same base. I'm going to turn them into a single log by bringing that exponent back in, turning this into there, 2x to the power of 2. So that coefficient of 2, I'm going to turn it and pretend that it was originally an exponent. What does that give me? It gives me the argument that 2x to the power of 2 is the same as x, or 4x squared is the same as x. And if I were to solve it, I'm going to continue on. 4x squared minus x equals a 0. What values of x make this work? And all of a sudden, it becomes a normal quadratic. I'm going to sit here and hopefully someone will tell me what my final step is. And from there, we are dismissed. And this is the end. Once we finish this, I'm going to quickly run through the Chapter 7 assignment for you, giving you an idea of what you should be able to do so far with what we're taught today. And yeah, take on any other questions you might have. Who's got the final suggestion? What am I missing? Anyone? No? Okay. Oh, one person. A domain, something, a positive. I'm not sure if that was from here. Something about a domain. It's true. One of these numbers actually I cannot use just like before. Go back to the original question. If you take a look, x to the power of 4, x equaling 1 over 4 is a-okay. There's nothing wrong with that. But if I have the x value as a 0, what happens to the actual logarithm? Well, it's not possible to do, right? 4 to the power of what gives me a 0? Like 4 to the power of what gives me a value of 0? Nothing. And therefore, this once again has to be rejected. It's an extraneous root. There. Right? That's pretty much it. So put x into the values equated. Yeah. Yes, you can test it, essentially. What Josh is saying is correct. You can essentially test it. You can see whether it works or not when you're in doubt. And that brings us to the end. Okay, you can take a look at our video for our recording for today if you want to review. I want to quickly bring your attention to our assignment. It's already on our Brightspace. Let's see. There, it's already on our Brightspace right here. And you can, I'll open it up. I think this is what it is. I have downloaded it, right. Nope, I must have closed it. Give me a second. There it is. Share my, there. Okay, so at this point in time, with the examples we've done for 7.2 and 7.4, you should be able to accomplish exponential laws. So here is one of those funky examples. Does that look familiar? See if you can accomplish this with a substitution, right? Same idea. This is a harder one, but I still think you'll be able to do it. All of these are very reminiscent of your spicy questions. Numbers 4, 5, and 6. Let's see which ones may still be a little bit out of your league. All the logs are the same base. I think you can do it. They're all the same base. Here is one where you have to, it is a log, but you're going to have to manipulate, get rid of the root so that you can exclusively work with exponents only. So you don't have to work with roots ever again. Here's another one where, please note, this is not log y to the power of 2. This is log y times another log y. Okay. I wonder how that might trip you up, but we shall see. Okay. Honestly speaking, with all the examples we've done together, these questions are not above you. However, the only thing that might be keeping you from being successful here is simply practice. So my recommendation, at least for today, because you do have time for this, at least for today, familiarize yourself, get some more experience, with some textbook questions and some logarithms. I also have for you a set of, this is not mine, okay? Don't judge me. It's a set of tangy questions for you, not spicy. This time it's tangy, and I will make them available right here. You can try those. Tomorrow, when we get together, we are going to do nothing but 7.4, as many tangy questions as, as many tangy questions as you would like to take up. And the remainder of the period you can use to essentially finish off chapter 7 assignment. Okay, you know what? I will do that right now. So 7.4, I am going to add in. Am I sharing screen with you right now? No, I haven't. So let me add in. As I was saying, in our schedule, if you look up, we're going to do as many tangy questions tomorrow as you wish, because tomorrow is exclusively 7.4. which means you don't have to worry too much. We have lots of time to practice this together. I am going to, as I said, update tangy questions. It's just a JPEG, an image file. I haven't had the opportunity to scan the document to make it permanently digital. Where is it? Oof. Anyways, I'm gonna do that right now before 11:30 passes. The questions will be available here. Your homework is going to be do 7.4 text questions, try tangy questions on bright space. Okay, come with questions tomorrow. And that's it. Any questions for me before we close? I'm gonna turn off recording.